Hello everyone. Let us discuss about system of linear equations. Before starting with linear equations, let us discuss first about echelon form. A matrix A is said to be in echelon form if the number of zeros before the first non-zero element in a row is less than the number of zeros before a first non-zero element in the next row. Look at an example. Number of zeros here before the first non-zero element is 1. In the next row it is 3. So here the number of zeros less than the number of zeros in the next row. So this matrix is said to be in echelon form. Next, rank of a matrix. Let A be a non-zero matrix. Rank of A is defined as the maximum of the orders of the non-singular square submatrices of A. By convention, rank of a zero matrix can be taken as 0. Let A be a non-zero matrix of order 3. Then rank of A is said to be 3 if A is non-singular. That means det A is non-zero. If det A is 0, then rank is said to be 2 if A is singular and at least one of the 2 by 2 submatrices is not singular. And rank is said to be 1 if every 2 by 2 submatrix is singular. And rank of a matrix which is in echelon form is equals to number of non-zero rows of the matrix. Next, consistent and inconsistent systems. The system of linear equations are said to be consistent if it has at least one solution and said to be inconsistent if it has no solution. Let us first discuss about non-homogeneous system. Look at the set of equations. The system of equations is called non-homogeneous equations. Method of solving the set of non-homogeneous equations. First, let us see the rank method. The given system of equations, first let us write in matrix equation form, which is A1 B1 C1, A2 B2 C2, A3 B3 C3, which are the coefficients of x, y, z taken in order. So which is called the coefficient matrix, which is denoted by the matrix A, and the variables of the given set of equations taken in one matrix, which is called the variable matrix. So the matrix xyz can be denoted by the letter x, and the constants of the set of equations taken in order, which is called the constant matrix, which is denoted by the letter t. So which is called the matrix equation form Ax equals to d. So the set of equations can be denoted in the matrix equation form as Ax equals to d. First we find out rank of A and rank of AD. Both the ranks is equals to 3, then we say the system of linear equations has unique solution. Next, rank A, rank AD equal but less than 3, then we say the system of linear equations has infinitely many solutions. And if rank A not same as rank AD, then the system of linear equations has no solution. So this is called the rank method, which is very useful for applying in the problems related to the system of linear equations. Next, matrix method, let us see. The given system of linear equations can be written in the matrix form, matrix equation form Ax equals to d. First, let us discuss the case when det A non-zero. Then if det A non-zero, then A inverse exists. So pre-multiplying A inverse on both sides, we get x is equals to A inverse into d. So for finding the variable matrix x, which is xyz, we get the values of xyz by multiplying A inverse into the matrix D. Next, what if det A equals to 0? Then we check adjoint A into D. If adjoint A into D is also 0, then we conclude that the system has infinite solutions. And if adjoint A into D is non-zero, then we say the system of linear equations has no solution. Next, let us discuss about homogeneous system. The system of linear equations a1x plus b1y plus c1z equals 0, a2x plus b2y plus c2z equals 0, a3x plus b3y plus c3z equals 0 is called system of homogeneous equations. You can observe here there are no constants, so every term is of degree 1, so homogeneous equations we can call these as. Solving the system of homogeneous equations, first by rank method. Given system of homogeneous equations can be written in the matrix equation form as Ax is equals to O, which is a zero matrix which has no constants. We will find out rank A. If rank A is equals to 3, then we say the system of homogeneous equations has trivial solutions, which means x equals to y equals to z is equals to 0, which in other way you can call as zero solution also. If rank A is less than 3, then we say the system of linear equations has non-trivial solution, in other words non-zero solution, which will be infinite in number. So you can remember one point, if det A equals to 0, then rank of the matrix will be less than 3, then the homogeneous system has infinitely many solutions. And if det A is non-zero, then rank A will be equals to 3, then the homogeneous system has unique solution and it will be trivial solution only. And from all these points we can conclude that homogeneous system of equations always has at least one solution. Look at an example. We need to find number of values of k for which the linear equations has a non-zero solution. These are the options. So 3, 2, 1, 0. The right answer is 2. You can observe the given system of equations are homogeneous. So given set of equations has non-zero solution, then det A equals to 0. So det of the coefficient matrix is equals to 0. So which you get after simplification a quadratic equation in K for which two values of K we get. Let us see one more example. A is a matrix of order 3 by 3, which is a lower triangular matrix. U1, U2 are the column matrices such that AU1 equals to 1, 0, 0, AU2 equals 0, 1, 0, then U1 plus U2 equals to. Observe the options. Right option is D, 1 minus 1 minus 1. Let us see the solution. Given the matrix A, so of its det value is 1. Finding A inverse using the formula 1 by det A into adjoint A, we get 1, 0, 0, minus 2, 1, 0, 1 minus 2, 1. And given AU1 is equals to 1, 0, 0, AU2 is equals to 0, 1, 0. So which by adding both the equations we get A into U1 plus U2 is equals to 1 0 0 plus 0 1 0, which you get A into U1 plus U2 is equals to column matrix 1 1 0. So we need the matrix U1 plus U2, so which you get by pre-multiplying A inverse on both sides. So which implies U1 plus U2 equals to A inverse into 1 1 0. A inverse, already we got the matrix which you can substitute, and after multiplication we get the matrix 1 minus 1 minus 1. Let us see one more example. If t is real and lambda is in terms of t, then the number of solutions of the system of equations is. Look at the options. 1, 0, infinite cannot be determined. Let us see the solution. Given set of equations are non-homogeneous, of whose augmented matrix we can take, which is the combination of coefficient matrix and the constant matrix. Let us convert this augmented matrix into the echelon form. So before that, let us interchange rows 1 and 2, using the row operation. So we get 1 2 minus 3 minus 2 3 1, sorry, 3 minus 1 4 3 6 5 lambda minus 3. So to convert into echelon form, we need to make these elements zeros, so which you get by applying the operations. R2 implies R2 minus 3R1, R3 implies R3 minus 6R1, which can be converted in this form. As we discussed, the echelon form, the number of zeros before a first non-zero element must be less than the number of zeros in the next row. Here in both the rows number of zeros is 1, so we need to make one more 0 here, so which you get by applying the operation R3 minus R2, which after simplification we get 1 0, and here in the next row 2 zeros. So the matrix is said to be in echelon form. So based on this value, we can decide the number of non-zero rows. So if this value is 0, lambda plus 5 is equals to 0, then lambda is equals to minus 5. But given lambda is t square minus 3t plus 4 by t square minus 3t, plus 3t plus 4, so which is equals to minus 5, so which on simplification you get a quadratic equation in t, which is t square plus 2t plus 4 equals 0, which implies t value will be imaginary. But given t is real, hence t cannot be an imaginary. Hence lambda plus 5 should not be 0. So if it is non-zero, there is one non-zero number in the last row, hence the rank of AD is 3 and rank of A is also 3. Both the ranks are equal and equals to 3, hence the number of solutions will be only 1. Thank you very much.